This is the site from where you can download. This is the site from where you can download the Smart PLS, and you can simply use the Google site in order to search this site. And this site may also require, when you have installed the Smart PLS, it will also require you to update the current version. So kindly you can update the version and you can start it functionally. So I have the trial version also. It will be its license will expire on 22th January. Therefore, I have started it from today for this training session, because today is 19, tomorrow is 20, and on 21 its license will expire. So after the license expire, you can download on another window, on another system. You can use the another email that you have not provided previously. So you can use with full functional procedures for your Smart PLS over here. So if you have downloaded and if you have installed, please let me know so that I can start over here. Please upload Smart PLS session. I was actually looking for PLS session. Will watch the recording of today's session later. All right, all right. Don't worry. I will upload all the recording tonight, and these recordings will be available to you. So don't worry. The Smart PLS setup has also been uploaded in your you can say relevant WhatsApp group. You can download the Smart PLS setup right from there. If you are familiar with the Smart PLS site, you can directly download from there. So if so, please let me know if you have installed the Smart PLS with the instructions that I have provided. Then I can start the Smart PLS procedure. So please let me know if you have done it. All right. When you open the Smart PLS, you see a picture like this. It will require you at the first instance that you need to provide him a workspace. It is like an office space that you want to work with. So you need to let them know that at which workplace or at which workspace you want to work with. For example, I want to establish at the desktop a new folder like my Smart PLS training. For example, this is the name of my workspace. So I can select this folder, and it will appear here, my Smart PLS training. So at first you need to provide the name of the workspace that you want to open. The second step is you can see there is an option which is open with the name of name project. Then you have some options which are dim, which are not active, like PLSM, like CBSM, like process, like regression. So what you need to do is you need to create a project. It means a task that you are going to perform using the Smart PLS. So I am performing a new project which names task 1. Let's suppose this is the first task I am going to do in my workspace. So I need to create the task 1. When I created the task 1, you can see that the remaining 4 options are open, like PLSM, CBSM, process, and regression. Here under task 1, you are seeing two different options like import data files, and the second one is create model. First of all, you need to import data files, but before importing the data files, I will let you know that you should have a data file which is basically readable by Smart PLS. In the previous version, it was not possible for Smart PLS to directly load an SPSS file, but in this version, it is possible for Smart PLS to load the SPSS file. So you can simply load an SPSS file over here, like our example data set, we can load it here. But previously, in the previous version of Smart PLS, we cannot load our SPSS file. We need to convert our SPSS data set into CSV file first, and then we can load it into Smart PLS. But the present version of Smart PLS is very much efficient, and the company has added some values in their setup so that it can recognize the SPSS dataset as well. So you need to double click it. It will load here and it will show you how much values do you have. Uh, I can click on the import button, and it will show you the raw values as well as the other values. You can see here example final data set indicators. There are 54 indicators or 54 factors in my data set. Number of observation are 456, and there is no missing value. You can also see the raw data. You can click over here, and you can see the raw data, like the data set in your SPSS. You can see the raw data over here. This is the file I have shared with you in the previous uh, two or three sessions previous, and I have shared this file with you. So this is what you need to do. At first you need to upload your data over here. Now you need to click back button. You have uploaded data set over here. You can see example final data set with the number of observation. Now the next thing you need to do is you can create model. You simply go and you let them know whether you want to use PLSM or you want to use CBSM. I want to use the PLSM, partial least square method. There is a difference between PLSM and CBSM. I will let you know tomorrow, because I could not copy the files, the PowerPoint files that I have provided the procedure, why to use the CBSM and why to use the PLSM. So I will let you know the difference between PLSM and CBSM tomorrow. But today you need to learn how to drive the PLSM, how to use this PLSM, and how we can analyze the different procedure using PLSM procedure. So you need to choose PLSM, and you need to provide the name of your first model. Like the first model in the PLSM is basically measurement model. Whenever you analyze the model using the SEM procedure, the first model you need to use is the measurement model. So click save button, and it will show you uh, the screen like this. And you can see here there is an file which is there is an area which is indicating the variables name, the factors name that are available with you. There is an area, the blank area, where you can draw your model, and you can see number of tools available in the first row. There are some menus over here. You can see uh, a number of menus available for you. So you simply what you need to do, you need to create your model first. For example, you can see here SDT1, SDT2, SDT3. If you click on control button from your keyboard, and you simply click factors one by one up to SDT6, and then you drag these factors over this area, it will show you the name of the main construct, which is SDT. Just simply click the enter button, and it will look like this. It means that your variable SDT is measured by SDT1, SDT2, SDT3, SDT4, SDT5, SDT6. We are expecting that these six factors are measuring our scale, which is SDT. You can change the direction of these factors from right to left. How can you do it? You simply go to the construct. This is called the construct. This circle is called the construct in the language of the smart PLS. So you need to right click over here. You need to select align to the left, and it will go on the left side. If you want to put them, let's suppose on the upper side, you can align indicators to the top side. Similarly, you can change direction in any way that you want, like this. So I am much more convenient that I want to take them on the left side. Let's suppose this is your one of the indicator. Let's suppose we need to put another indicator with LDT. So I need to drag in the same way LDT over here. I need to click enter, and you can see here my second indicator has appeared. I need to put it again on the left side. You can also minimize like this. You can change your view of your picture from here. There is there is a slide available, horizontal slide. You can change it from here. So two indicators appeared here, and you would like to know how they are related, how they are not related. Let's suppose these are the independent variable, and we would like to see their impact on, for example, like on PS. This is the basically variable that we are interested during our case process, that is project success, and these are the factors of project success that we are interested to analyze. So you can copy them and you can paste them over here, and it is automatically put it on the right side. So let's suppose SDT and LDT are the independent variable or exogenous variable, and PS is the dependent variable or endogenous variable. So how can we connect? How can we see the impact of both of these two variable on this? Simply, you need to select the connect button from here. You need to connect STT. You need to connect LDT. One thing more, I would like to let you know that you can change the color scheme of these circles along with their factors. There is an option of coloring. I would personally prefer coloring black and white. So you can do this in this way. So what you need to do at first, you need to go to the calculate and you need to run the PLS algorithm. This is the first option that we need to apply in the SAM procedure when we want to know whether the relationship between IV and DV is good or not. I have also told you the difference between CFA and EFA in the start of my lecture. I have told you when you need to develop a scale or you need to validate a scales of items, you need to use EFA. But if you have already validated scale, you can use the confirmatory factor analysis. So in smart PLS, we can use the confirmatory factor analysis. So there is an option of factors. You can select it. You can click on the start calculation button, and it will show you within a couple of seconds the results of your confirmatory factor analysis. You can see here in this picture with SDT, there are some values on the left side. Like you can see SDT1 is indicating 0.805. This is the factor loading value, same as you have seen in here. This is the values like in our EFA analysis. These are the values we consider as a factor loading. In the same way, when we do the CFA analysis, these are the values which are considered as a factor loading. The basic criteria of accepting any factor is that the value should be at least 0.70. So here we can see that STT1, STT2, STT3, STT4, STT5, and STT6 all are showing a value greater than 0.70. So we can conclude here that STT1, STT2, STT3, STT4, STT5, and STT6 are basically Meyer STT component or STT construct or STT scale significantly, because these values are greater than 0.70. In the same way, you can see LDT, its factor loading values all are greater than 0.70. So we can say that LDT1 to LDT5, they are measuring LDT constructs significantly. In the same way, you can see here, uh, you can see here the PS, that is project success, and you can see the factor loading value are higher than 0.70. There is no value which is less than 0.70. So we can say that these values are basically significantly calculating the PS construct. Now, what about these two values and this value? Basically, this value is basically the path coefficient value. It means that STT is impacting the PS with positive impact. In the same way, LDT is impacting the PS with positive impact. So it is a path coefficient value. You can say it is a coefficient value. So this is the coefficient value for this particular path, and this is the coefficient value for this particular path, and both are positive. It means SDT is positively impacting the PS, and LDT is also positively impacting the PS. Now, what is 0.912? This is basically the R square that during regression we came to know that how much variance in the dependent variable is explained by the variance in independent variables. So SDT and LDT is explaining 91.2% variance in PS. So this is how we can analyze our basic model. The other thing we can see over here, if you go to the left side, you can see there are a lot of options available over here under the final results. First of all, you need to open the path coefficient. If you click it, you can open the matrix option over here regarding the path coefficient. So the same values that we have seen in the graphical output, the same value appear over there, like 0.425 and 0.568. You can see in the path coefficient table, and you can simply copy these values to Excel. So you simply click it, and you can put it into Excel sheet. Like for example, if I want to put uh, the output over here, I just need to click copy to Excel, and I can put it over here, Control V, and you can place over here. It is very simple. In the same way, you can see, just a minute, you can see over here the total effects matrix, and it will show the same values. The important things that you need to see is outer loading. That is very important, and you will see the matrix form of your outer loading. This is the same as I have shown you in our EFA procedure. It looks like this, that how many components are there. It is basically the outer loading in EFA procedure, rotated component matrix. So you may consider it outer loading in case of EFA, while this is the outer loading in case of CFA. That is confirmatory factor analysis. So these are the similar values, and this should be greater than 0.70. And in case of confirmatory factor analysis, your values should be greater than 0.70. So these are the values, and you can verify these values from the graphical output. The same values appear over here. So the outer loadings are greater than 0.70 in all our constructs. Similarly, another thing that you need to see over here, that is the construct reliability and validity, which is known as convergent validity. You may have heard about Cronbach alpha, that during training session of SPSS I have told you that how to calculate Cronbach alpha, but SPSS, Smart PLS automatically calculated. We don't need to run any additional procedure. We don't need to run any separate procedure for that. It will run automatically using the same algorithm that I have previously used. So it is showing Cronbach alpha for LDT, for PS, for STT, and it is greater than 0.70. So the value of Cronbach alpha should also be greater than 0.70. Then there is a composite reliability, which also shows the reliability of your variables or your constructs. It is also greater than 0.70. Then your composite reliability, again, it is showing greater than 0.70. Then average variance extracted, it also shows the validity and reliability of your scale. So the minimum value of AVE should be greater than 0.50. So it is greater than 0.50. That is why their values are looking like in green color. So you can also copy these values. It can be shown in your output windows. I can put it over here. Cronbach alpha, composite reliability, composite reliability, average variance extracted. I can use them uh, for my publication process, for my article publication, and so on. You can also see here the discriminant validity. That is another type of validity which we use in our process, and you can see these values are looking in red color. It means there is a problem in discriminant validity. These values should be less than 0.90 according to HTMT criteria. The discriminant validity for HTMT is basically established when the values are less than 0.90. So these values are greater than 0.90. It means there is no discriminant validity in our data. So what does it mean? It means that our constructs, if I show you the graphical output, what does it mean? If these factors actually measure the SDT, it means the construct validity or scale validity of SDT. But sometimes it happens that these factors may also measure the PS, or these factors may also measure the LDT. So when the factor of another scale are measuring some other or some different scales, or they may correlated with the factors of other scales, it means that there may be a problem of discriminant validity. Discriminant validity means that the factors should discriminantly measure only their scale, but do not they should not measure the other scales. So there may be a problem where there is a correlation in the factors. That is why uh, they are looking like a red. If outer loading is less than 0.70 or 0.50, what to do? There is a very simple procedure. If you have a number of factors for a construct, and you can afford to lose a factor, you can lose it. Simply, for example, let's suppose I want to, I will show you from here. Let's suppose if we consider the PS, if we consider our model for PS, you can see there are a lot of factors over here. There are 16 factors over here. We can lose one or two factors from here if the value is less than 0.70. But in case if you consider like SDT or LDT. In LDT, there are five factors. Let's suppose three factors are here, which values is less than 0.70. So there is another criteria. Some of the studies recommend that you can retain a factors with at least a value 0.50, if you don't want to lose it. But if still your value are less than 0.50, then it means there is a problem with your data set. There may be a problem in your data entry. There may be a problem with your statement. You need to revise your statement. You need to collect your data, or you need to collect more data. So this is basically the solution that you need to understand. So in case of discriminant validity, there are three criteria that we need to check. First is the HTMT. In case of HTMT, the ratio should be less than 0.90. There is another criteria which is known as Forner-Lorker criteria. You can see here there are some value like the first value of LDT is 0.851. Uh, in order to establish the Forner-Larker criteria, the values in a same column should be less than the first value of that column. For example, if we can see the second value, which is in front of PS, it is greater than the first value of the same column. It means the discriminant validity is also not possible here. So this should be less than the first value. Similarly, if we can see the PS column, you can see the second value is greater than from the first value. So in order to establish the Forner-Larker criteria, the values after the first value should be less than the first value of that column. Then there is a cross-loading procedure. The meeting is going to end within a 1 minute. Let's have another meeting, or the last meeting of this today's session, in order to complete our basics understanding of smart PLS. So I will request you, all of you, to please join this session again for the last part of today's training, so that we can cover the basics understanding of